Welcome to part two on our discussion on mathematics and language. So, in the previous part, we have discussed how we can express certain mathematical expressions in conversational English and vice versa. How from an English, a sentence or a phrase that involves quantities will be expressed mathematically. And one of the applications that can make use of this is the word problems. What I will be discussing here with you now are common word problems that would appear in the civil service exam. So I've done a lot of reviews already, and these are the common word problems that I would see. So just as a recap, we would be expressing quantities. So if we have a number, then we can use the variable x for that. Now, one of the common word problems is on consecutive numbers. So if you start with a number, say x, then the number after that is x plus 1, and the number before that is x minus 1. So let's say your x is 5. The number that comes after 5 will be 6. So that is x plus 1 or 5 plus 1. And the number before 5, of course, is 4. So that's x minus 1 or 5 minus 1. So if we are going to add two consecutive numbers, then you can express that as x plus 1. On the other hand, if you will be adding three consecutive numbers, then you would have x, which is the first number, plus x plus 1, which is the second number, plus x plus 2, which is the third number. Now, if you would be multiplying two consecutive numbers, then you would be multiplying x and x plus 1, as what we have here. Now, if you say twice the number, of course, that will be 2x, 5 less than the number, so that is x minus 5. And then the sum of the first and twice the second, so we have x plus 2 times x plus 1. Now we can also have consecutive odd or even numbers. So just to recap, odd numbers, those are the numbers ending in 1, 3, 5, 7, and 9. And then for the odd, I'm sorry, these are the odd numbers. And then for the even, these are the numbers ending in 2, 4, 6, 8, and 0. So you will notice going from 1 to 3, you add 2. From 3 to 5, you add 2. You add 2. You add 2. From 2 to 4, you also add 2. So from 4 to 6, you also add 2. 6 to 8, you also add 2. So if you have consecutive odd or consecutive even numbers, your first number is x, your second is x plus 2, your third is x plus 4, and so on. So if you would say you want to find the sum of two consecutive odd numbers, then you would write that as x plus 2. If you would write, if you want to find the sum of three consecutive even numbers, then you will have x plus 2 plus x plus 4. And if you want to find the product of two consecutive odd numbers, then what you would have is x times x plus 2. So let's have here an example. So you want to find the sum, or the problem will be stated this way. The sum of two consecutive numbers is 5. Find the smaller number. Of course, this one is a very simple problem. So to illustrate, so the sum of two consecutive numbers, so you have x plus 1, and this is equal to 5. So implicitly, we have here equality. So this is the same thing as saying the sum of two consecutive numbers is equal to 5. So even if we do not have uh, an implicit uh, declaration of equality, so we understand that it means equality. So here we have x plus 1 is equal to 5. And then, of course, we solve this using our basic algebra. So x plus 1, so you'll have 2x plus 1, that's equal to 5. And then transpose 1, so you have 2x is equal to 5 minus 1. So you have 2x is equal to 4. Divide by 2 both sides. So x is equal to 2. So if your first number is 2, Then your second number, of course, will be 3, and we can verify that 2 plus 3 is equal to 5. So it fits the conditions that are given in the problem. Let's have our next example. Three consecutive integers have a sum of 33. So find the three integers. So since we have three consecutive integers and their sum is equal to 33, so the three consecutive integers, we write that as x plus 1 plus x plus 2, and then this is equal to 33. So again, we do basic algebra here. So we will get 3x plus 3 is equal to 33. Then 3x is 33 minus 3. 3x is 30. Divide by 3 both sides. So x is equal to 10. So the smallest integer is 10. Then of course, what's next is 11. Sorry, not there. So the numbers are 10, 11, and 12. And you would verify that 10 plus 11 plus 12 is equal to 33. Now let's have another example. Find three consecutive odd integers such that the largest is twice the smallest, less 3. Okay, so this time what we are looking for are consecutive odd integers. So our let's just write the smallest. We would have x. The next one will be x plus 2 since these are consecutive odd, and then the third one is x plus 4. And then it now gives the condition. The largest is, so this one again implicitly you have there is equal to. So the largest, of course, the largest number here is x plus 4. So the largest is equal to twice the smallest less 3. So that's twice the smallest. So your smallest here is x less 3. So this is our equation. X plus 4 is equal to 2x minus 3. Then, of course, we apply now our algebra. So we will have 4, I'll transpose this 3 here. So, and then 2x and then transpose x. So 7 is equal to x. So our first number is 7. Since these are consecutive odd integers, so our numbers are 7, 9, and 11. Now let's check the condition. It says that the largest is equal to twice the smallest less 3. So 11 to know is equal to 2 times 7 minus 3. And 2 times 7, that's 14, minus 3 is equal to 11. So the condition matches. Okay. Next, we have find three consecutive even integers such that the sum of the smallest and twice the second is 20 more than the third. So we have three consecutive even integers. So again, we will have x plus 2, and x plus 4. So please don't be confused. Even if we have consecutive odd or consecutive even, then it's the increment is always plus 2 plus 4. All right, so the condition here, the sum of the smallest and twice the second is 20 more than the third. So the smallest, of course, is x. So the sum of, so x and twice of the second is equal to 20 more than the third, which is x plus 4. So this is how we write the the equation that matches the given in the problem. So again, it says the sum of the smallest and twice the second. So this is the smallest. This is the second. So twice the second, you multiply by 2, the whole thing x plus 2. And this should be equal to 20 more than the third. So this is the third. And then again, applying algebra here. So we'll get x plus 2x plus 4 is equal to x plus 24. And then let's simplify further. We have 3x plus 4 is equal to x plus 24. Transpose. We continue here. So 3x minus x, we get 2x. This is equal to 20. So x is equal to 10. So we will have our smallest number is 10, and then next, of course, is 12, and then 14. So let us check The sum of the smallest and twice the second. So 10 plus 2 times 12 is this equal to 20 plus 14. So 10 plus 24 is this equal to 34. So yes, they are both equal to 34. So the numbers that we got, 10, 12, and 14, matches the or are sufficient for the conditions given in the problem. Okay, let's have our third example here. So find three consecutive even integers such that their sum is 50 more than the largest integer. I'll be leaving this one as a problem for you to solve. Now, another application of math and language is in solving age problems. So, when we are solving age problems, we would always, usually, we would have two, sometimes three, but the most common, we would only have two persons involved. And the age of one person is based on the age of the other. So the person whose age is not defined in terms of the other is his age or their age will be assigned as X. And depending on the conditions given, then we will make a mathematical expression for the age of the second person. So in this example, let's say we have here, let's have an example. Okay, so we have here Juan is 6 years older than Pedro, and we have this condition that 6 years ago, Juan was twice as old as Pedro. So the question is, how old are they now? So in this problem, we see that Juan's age is given in terms of the age of Pedro. So the age of Pedro right now, we will set that as X, and the age of Pedro, I mean, the age of Juan will be X plus 6. Then we have the other condition, which says that 6 years ago, so if Pedro's age right now is X, then his age 6 years ago must be X minus 6. And on the same manner, Juan's age right now is x plus 6, so his age 6 years ago must be x plus 6 minus 6, or of course you can simplify that as simply x. And then how will we now form the equation? So the equation will be based on the second sentence here, which says 6 years ago, Juan was twice as old as Pedro. So this age of Juan, this age is times 2 this age. So this is exactly how we write the equation. This is the age of Juan 6 years ago. It is double the age of Pedro 6 years ago. And of course, we would apply our basic algebra to solve this. So we will get 2x minus 12. This is equal to x. And then this will be 2x minus x is equal to 12. So x is 12. So Pedro's age right now is 12, and Juan's age right now is 18. If that is the case, what is the age of Pedro 6 years ago? That would be 6, and the age of Juan 6 years ago will, of course, be 12. Now let's check the condition. It says Juan was twice as old as Pedro. So Juan's age 6 years ago is 12, which is double the age of Pedro 6 years ago, which is 6. So this is how we solve an age problem with these conditions. Let's have another example. So we have here a man is 3 times as old as his son. The sum of their ages is 48 years. So the question is, how old is the son? So the age of the man is based on the son. So we will set the age of the son as x and the age of the man as 3x. And then the condition here, the sum of their ages is 48 years. So it does not give any condition of the past or the future. So we are just basing on the present or their ages now. And that's the only condition. The sum of their ages is 48 years. So the age of the man is 3x. The age of the son is x. So if we add them, we should get 48. So again, applying algebra, we get 48. 4x is equal to 48. So x is 12. So the age of the man is 12, and the age of the age of the son is 12, and the age of the man is thrice that. So that should be 36. Now let's have basically the same conditions, the same situation. We have a man being 3 times as old as his son, but now the condition has changed. Wherein 4 years ago, the sum of their ages was 60 years. So how old is the son, or how old are both? So again, we'll make the same table. So we'll have the man and the son, and their ages now, and their ages 4 years ago. So the age of the son is x, the age of the man is 3x. So 4 years ago, that would be 3x minus 4 for the man, and then the son would be x minus 4. So the condition states that the sum of their ages 4 years ago is equal to 60. So we just add 3x minus 4 with x minus 4, and we should get 60 here. So solving that, we get 4x minus 8 is equal to 60. 4x is equal to 52. Sorry, let me do that step by step. The 60, sorry, that should be 60 plus 8, not 60 minus 8. So 4x is equal to 68. So divide both sides by 4. So x will be equal to 17. So right, 68 divided by 4. 6, 1, 4, 28, 7. Exactly, 17. So the son is 17 years old, and the man would be 3 times 17 is 51. So if this is 17 and this is 51, so 4 years ago, the son would have been 13, and then the man would have been 47. So if we add 47 plus 13, so yes, that will give us 60. So it matches the condition. So our answer here, wherein the son is 17 years old, is correct. So these are just some of the examples that we have wherein we can make use of math and language in solving word problems. And again, this will be very helpful for those who are planning to take the civil service exam. So familiarize yourself on how these are being used. That ends our lesson on this part. See you on the next lesson.